Welcome back to the APSCC 2021 webinar series. I'm Christopher Slaughter, your MC for the series. Today, the conversation is GEO versus LEO, implications for military satellite communications. We're very happy to cover this subject today, not necessarily an area that we spend that much time talking about, but obviously a critical part of the business stream for the industry is government and military satellite communications. Joining us today, Carissa Christensen from BryceTech will be moderating the panel. She's also speaking to Nick Shave from Inmarsat, Doug Lavero from Lavero Consulting, and Jerry Johnson from Telesat. So please take it away, Carissa. Thank you.
Hello. It's a pleasure to be here today with a panel to discuss the military applications of GEO versus LEO satellites with a group of panelists who are in the middle of making those decisions and advising senior leaders on how to think about those decisions. So joining us today, we have Jerry Johnson, Government Satellite Solutions Director from Telesat US Services. Telesat is a leading GEO operator and is, of course, developing a large constellation of small sats to augment its capability. Jerry is the point person for US government solutions around Telesat's offering. We are also joined by Mr. Douglas Lavero, a senior defense executive from the US. Doug had a long career at the Department of Defense and National Reconnaissance Office. He ran the Air Force's, now the Space Force's, Space and Missile Center, which purchases major systems for the Air Force, now the Space Force. And he served as the head of space policy in the Pentagon. He's a highly sought after advisor today. And then finally, we are joined by Nick Shave. Nick is the chair of UK Space, the trade association of the UK space industry. The UK government, of course, has made an investment in OneWeb, arguably the first very large LEO constellation of small telecom satellites. Nick is also the VP for strategic programs at Inmarsat, an operator offering GEO services to a wide variety of telecom customers, particularly maritime users. So we've got exactly the right panel today to explore this question. And what I want to start with is the general question of the relative benefits of a LEO smallsat telecom constellation versus a large GEO ComSat. GEO ComSats have provided extraordinary benefits to the world for decades. We rely on them for for internet, for many other applications. So let's talk a little bit about the relative pros and cons at the very top level. And Nick, do you want to kick us off and talk a bit about that framing, and then Jerry, and then maybe we'll end up with Doug?
Thank you, Carissa, and very pleased to be here on this panel today. Yeah, in terms of the relative benefits, I think one phrase I'd use, perhaps an English phrase, is horses for courses. It's very much, I think, GEOs have been there, as you say, Carissa, for some time. We've got lots more non-GSOs now coming with LEOs, but also other networks in MEO and highly elliptical orbit as well. And I think in terms of relative benefits, I would say that obviously the GEO environment, you can provide coverage to most of the Earth's surface with only 3 satellites. And most of the networks, satellite operators we see today who are GEO-based, overlay and layer capacity, which is particularly useful for governments when you're looking for communication certainty and high capacity in short periods of time. You're fast when deployments happen, for example. You might not know where you need to be at a certain time. You need to get there quickly. So that's the first thing I'd say. GEO offers that environment, whereas LEO offers other benefits, perhaps, as well. I'm sure we'll come on to that in due course. The other point I'd make in terms of benefits is GEO offers capacity flexibility per platform. So you can very fast deploy significant capacity to military platforms, government users, because you can provide a lot more capacity from a large GEO communication satellite than you can from a small LEO platform. And the final point I'd make is network aspects. So I think, and the return path in particular, there are a lot of discussions in the market at the moment about latency and how latency perhaps is a lot lower from LEO. That, in physics and the speed of light, that's obviously true. You're 6 to 7 times further out at GEO from the Earth's surface. However, it depends very much on the LEO network and how you route that capacity between where you are as a military or government user and getting back to your operational center, perhaps in your home nation or coordination center, and whether or not you're using inter-satellite links. So I think for many high bandwidth requirement applications, we don't think latency is that much of an issue, and it's a more complicated issue than just the space to ground delay. It includes inter-satellite link delays or ground network. So the final benefit I'll make from a GEO perspective is you need less ground stations because you only need a few in the satellite footprint compared to a LEO network where you might need hundreds. Thank you.
Thank you, Nick. That's a really helpful framing of many of the reasons that we rely on geosystems and the fit for purpose idea of using the right kind of system for the right kind of application in the future, all wrapped up in the marvelous English phrase, horses for courses. Jerry, Telesat is in the exact middle of this discussion. Telesat is a GEO operator delivering those benefits, selling those services to customers, and certainly characterizing the benefits and advantages of those services, and also investing quite substantially in a LEO system to augment those services. So help us understand the trade space that Telesat is thinking about.
Great. Well, Carissa, thanks for inviting me here today as well. So good point, right? So Telesat has been in the business for 50 years doing GEO services to its GEO customers, as Nick pointed out, providing all those services, those ubiquitous coverages over the Western Hemisphere. Right. However, as we look to LEO, we look to see as a new business, a new opportunity that now can provide that global coverage, that global connectivity that wasn't available before. So albeit as wherever you are on the Earth, you'll be able to be connected. And the advantage, of course, of the Telesat network includes intersatellite links, optical intersatellite links. So we're basically going to recreate a fiber-like experience in LEO domain. So the demand for ground stations is fewer because you have now this interconnectivity activity. You have low latency because now it's all about the experience, right? Can you get to a fiber-like experience that you'd get now using space assets? And of course, you can cover the globe, you can cover the poles, where this has always been a problem in the current domain where GEOs can't get above 70 degrees, northern latitude. So adding now polar coverage provides a whole new opening for services for warfighters and for transport across the north, and obviously for anything operating in the southern hemisphere as well. So it's really providing that full end-to-end connectivity piece now that allows for full use, and also providing, I'll say, high data rate, high bandwidth experiences that, in the GEO domain, you're still somewhat channelized to a smaller set of frequencies and then a smaller set of bandwidths. So in the traditional GEO world, a 36 megahertz transponder equivalent is what you use, and maybe you can push 50 megabits through that line. So you're somewhat constrained then because of the traditional channelization that's occurred in that space as well. With this now in the LEO domain, we open that up to small footprints, small beams, multiple users, high band and frequency reuse. So it really achieves a global, interactive, dynamic coverage that can go forward.
Jerry, do you, Nick sort of laid out a future where there's a very clear role for geosystems, there are clear roles for LEO systems, and they're not, one is not definitively dominant compared to the other, it's a blended system. Is that your view as well?
We agree. We agree. I think GEO doesn't go away. GEO does serve its purposes for a variety of capabilities. The multicast capabilities, the direct-to-home type services. These are really what we're seeing in the marketplace, and they're not really going to change because there is still a demand for those capabilities. However, as you start to move out away from that footprint, we see, and from a military application, you have a wide footprint on the ground. Where that interferer may be coming from is hard to triangulate and identify. However, with a small beam, with the LEO systems, you can now at least isolate, I'll say, bad actors from the mix. So you still have a place for both. I think they both serve the same, a different set of markets now, and that's the key. We can't use them for the same markets because really it's not applicability in those same areas.
So Doug, you are talking to companies, you're talking to government leadership on the military and civil sides, you're having conversations internationally. How do you frame this trade-off? How do you think about that? How do those folks think about this question?
Thanks for asking, Carissa, and thanks for inviting me here today. This is a great discussion and an important discussion. It's interesting. Nick and Jerry talked about some of the technical aspects and some of the system aspects of GEO versus LEO. One of the things that I like to think about is the mission aspects, the user experience. What does it mean to the user? And in the military perspective specifically, there's some very interesting differences that people don't realize all the time when we look at this, because when we think about the way the commercial world uses SATCOM, it's very different than the way the military uses SATCOM. So for example, in a military environment, I might be, let's say, in a country the size of Iraq, or even a smaller country, Kuwait, let's say, and I may have 50,000 to 100,000 users in that small area. Those users can't be served by a LEO constellation. Not that many users can go ahead and go onto a LEO constellation at one time. I need to go ahead and mass frequency in that constellation. And from GEO, I can do that. From GEO, I can position 4 or 5 satellites that can all access the same area and yet have a geometric and frequency differences. So I can mass frequency in one area. GEO is great for that, massing frequency, which oftentimes the commercial world doesn't need to do, but the military does need to do because we put a lot of people in one spot. On the other hand, LEO is fantastic, and Jerry just said this, to reach that distributed user anywhere in the world, anytime that we need to reach that distributed user. We can do it from LEO, and typically with a smaller terminal, then we can go ahead and support for a GEO user. And in fact, that's the reason why the DoD invested in Iridium back in the mid-90s, was to go ahead and serve those distributed users. And so this is a very different way of looking at it. That's point one, the ability to mass frequency versus the ability to serve users who are spread out around the world. The second thing is, and Jerry mentioned this, is jam resistance. This is incredibly important. Typically, the way the military has approached jam resistance is with hot frequency hopping, is with waveforms, is with melting antennas, is with these very high technical solutions, and they do work very well. And they're specifically very good for some purposes which need low bandwidth. But when you want to have high bandwidth and jam resistance, bringing the satellites down to LEO means that you have a far smaller geographic footprint, which means your jammer needs to be very close to the communicator. And so you get an inherent geometric jam resistance even before you lay on any of the technical capabilities that could go ahead and provide jam resistance. So that's a very important aspect as well. And then I already touched on the notion of terminal size, but just to put it more specifically, a LEO system, I can put small little patch antennas on an aircraft, on a Humvee, on anything, and I can communicate even at fairly high bandwidths. That's hard to do with a GEO system. On the other hand, with a GEO system, I can go ahead and maintain continuous communication even in the face of moving around at very rapid speeds, changing networks, things I will do things in the military, for example, from a UAV that may not have been planned for in a traditional LEO system, but I can go ahead and do that in a GEO system simply by going ahead and concatenating channels together. Jerry mentioned a normal channelization of 36 megahertz. Well, I have used GEO systems to go ahead and transfer data at rates of well over 300 to 400 megabits per second by going ahead and putting several channels together. That's harder to do on a processed LEO system, which has a very strict way of approaching the communication. So those are just some of the things that we talk about as we think about this from a military perspective.
So Doug, that's very helpful. And again, that speaks to the using the right system for the right purpose. And I think some of the points that you made are not typically widely discussed. There tends to be a view that a LEO system has more flexibility, and your point is for particular situations, there's a balance. So let's talk a little bit about why LEO versus GEO matters for military applications, in addition to the points Doug made around use patterns, around use cases. There's also a discussion and around the discussions that you tend to hear are around latency, and Nick talked about that a bit, and about resilience, and the fact that many small satellites, a distributed system, and this is a more general point, not narrowly limited to LEO telecom smallsat constellations, but certainly relevant. There's the idea that a group of small satellites is inherently more resilient than one large satellite because it is more difficult to disrupt all of the satellites, and that system of multiple satellites will be, in theory, robust to the damage or disruption or a degradation of performance of one element of that system and still retain system level performance. That's been and I want to talk about that in two ways. A, do you agree? Do you see that resilience benefit? And B, if there is a benefit, satellites take a long time to develop and deploy, and they have long lives if you're looking at the GEO regime. So transforming architectures is not a matter of years. It may be a matter of decades. So let's talk about pros and cons of resilience, and then let's talk about that transformation idea. Jerry, do you want to kick off on that?
Sure, thanks. So, obviously your points are right on from a resiliency perspective for the LEO capabilities. Multiple satellites providing multiple capabilities, transversing the Earth at a rapid speed, so not sitting overhead at any one time. And so therefore it can collect and continue to move, and next one can come into play. So it really provides a mesh capability. A lot of these networks, and ours inclusive, will be self-healing, so that in the event there is a failure of one of the satellites or jamming or interference that's occurring on one, there's adjacent satellites that are in view, so that at any one time you could have up to 5 satellites over a geographic area, providing multiple coverage, multiple views, multiple looks, and alternative paths to get information away from the contested, ingested area. And so it does provide that level of resiliency. Obviously, the quantity matters. And to your point, I think you highlighted earlier, it does take a lot less time to build small sats, right? And we're talking about, one a day is the phraseology that's being used, that they can be built. And then when you get the group put together, then you can launch that. So it does help in that sense, that you do get a lot of rapid refresh of technology that can occur because lifetimes are not the same scenario. So from a combination of rapid deployment and the resiliency that they bring as from a global mesh self-healing type network, I think you can achieve a lot more new capability and new knowledge as information is learned on how well you can respond. It can be brought to bear very quickly.
That's a pretty compelling characterization of the benefits of a LEO system. Again, I think that we're not in an either-or situation. We're at an A and B situation. Let's talk a little bit about resilience from a GEO standpoint. Nick, maybe GEO is not as certainly that the GEO arc has not been as subject to demonstrations of anti-satellite capabilities. Certainly, GEO satellites tend to not operate completely on their own as a single satellite. They're often part of a group of satellites that can provide some backup or alternatives. Can you talk a little bit about these resilience issues in the context of geosystems and offer any thoughts you might have on kind of the relative benefits in different situations?
Yeah, sure, Carissa. I think some very valid points made by both Doug and Jerry on this, obviously. And I think from a geo domain, there are most operators now are providing overlay capacity. So you have multiple satellites in view in your network for the user wherever he is in the world. Okay, maybe 80 to 80 north and south, that sort of level. I think you're right in saying that from a actual physical resilience perspective, the geo arc is a lot further away. It's harder to get to, and you got much less of a debris problem. We were all hearing about the debris problem only this weekend at a launch with a demonstration from a UK satellite, Astroscal. Looking at that issue, that's a big issue coming forward, space traffic management. And I know many of the LEO network operators are looking at sustainability issues in that area, which is excellent. But I think geo systems and the advanced digital payloads that we're seeing from a mission perspective offer significant enhanced resilience, even in the commercial domain. We're seeing a much more blurred transition, if you like, between traditional MilSatCom, which has the hardened characteristics that Doug mentioned, but more and more commercial operators are building that into their networks. So, thousands of beams being generated in GEO because of the digital platform payloads that we have, and AJ type capabilities and so on being provided by commercial operators. So we're seeing a blurring of what's available from a national to a commercial perspective. So I think geo resilience is increasing quite substantially as we go forward.
So Doug, I want to definitely hear your view on the resilience trait, and then also as the person who really bought major systems for a long time, how do you transition? How do you transition in architecture? Let's envision, a GEO platform moving to a distributed platform in GEO. How long is that going to take? What's that look like?
First, let me talk about resilience, Carissa. And I hate to put it this way, but I sort of wrote the book on resilience, right? Because when we were in DoD, it was actually my group that put that together, and it's interesting. There are these different facets of resilience. We talk about diversity, we talk about distribution, we talk about proliferation, we talk about disaggregation, we talk about protection, we talk about deception. These are the 6 tenets of resilience. But as humans, we tend to focus on the ones that are easiest to understand, and the easiest one to understand is proliferation. It's pretty simple to understand. You got a lot of things, and a lot of things has got to be better than a few things, right? But what we really need to understand is that an adversary gets a vote in the resilience of your system. You are not the only one who gets to choose it. So if I as an attacker want to go ahead and take down your network, if you're a GEO system, I'm going to go ahead and attack it in one way. I probably will do a one-on-one attack, and I might try to jam it, or I might try to do a physical attack in space. If you're a proliferated LEO system, I'm going cyber all the way. I'm going network attack. I'm going to go ahead and do that. So a single network attack can take down an entire LEO system in the same way as a single jamming attack can take down an entire geosynchronous satellite. So proliferation in itself, while an amazing thing if I was worried about only a single threat of a in-space kinetic attack, doesn't tend to be any better or any worse if I'm worried about a cyber attack. And so every system has its vulnerabilities. Every system has its attributes, and what you have to do. And gosh, Nick, what was the phrase? Horses for courses? Is that what it is?
Yes, there you go.
So you've kind of got to match. You've got to kind of match these together to figure out how you're going to do it. And what you need to realize is that if you move in one direction as a military, that you will go ahead and cause the attacker, the adversary, to change his thinking about this. And in fact, that's the reason why the most important resilience characteristic for all military systems is diversity, because diversity means that each system has a different weakness and a different strength, and an adversary needs to go ahead and now cover down on more than one kind of attack vector in order to go ahead and make that happen. And so this is one of the great things that's having GEO and LEO and MEO gives you. You get diversity in these systems because I can now use all of them to go ahead and so if an adversary happens to be a guy who's got great ability to do cyber attacks, maybe that's a military bought cyber hardened GEO system that's the best for that. On the other hand, if somebody's only got has got a great co-orbital attack capability in geosynchronous, but can't attack you in LEO, well, maybe that's the reason you want to use that. So it's the mixture of these things. And in fact, this is one of the things that the DoD has been bad at in the past. For space, we've only ever bought one kind of thing, as opposed to many kinds of things. And that's the true hallmark of resilience, is the diversity that you might get for it. Now, your second question is about transition time. Well, transition time sounds like it can be a long process depending upon your perspective. And too many people in the military look at it with the following perspective. Oh my gosh, I've got 200,000, 300,000 fielded terminals, and those terminals are designed for a specific system. It will take me too long to transition, and therefore I should not. And that's, unfortunately, it's that last phrase that becomes the bugaboo for the military, and therefore I should not. And so we get stuck on the old system. And that's the wrong way to look at it, because I can transition an individual user tomorrow. In fact, and you saw this in the news recently, the Air Mobility Command, the people in the Air Force who fly all the cargo around for the Air Force, you saw that they are talking about adopting Starlink into their airframes. They can transition to Starlink. A single user can transition to Starlink tomorrow if they choose to. It may take the day after tomorrow, depending upon how long it takes to get the aircraft back flying. But so if you view this from I have to transition the entire military at once, well, that becomes an anchor on your transition. If you view it as I can transition the right users at the right time, remember that Starlink user is going to go up into a network, which is going to be eventually connected to a geosynchronous user someplace else through the worldwide internet, through the ubiquitous quote cloud, the one we saw on all the charts all the time. But the fact of the matter is the cloud is really there. And so I don't need everybody to be on Starlink for me to talk to somebody. And if Starlink is right for me, or if OneWeb is right for me, or if Telesat is right for me tomorrow, I can transition tomorrow. And in fact, if you look at it, that's actually the way we transitioned from the satellites formerly known as Milstar, Discus, and UHF follow-on to now AEHF, WGS, and AEHF. Every one of them had a 20-year transition for the entire military, and yet simply a weeks or month-long transition for individual users.
So you hit on, I think, a really interesting point here that I want to tease out a little bit, and I'd love to get everybody's view on that. And I'm going to say that from the point of view of different satellite systems, as well as satellite versus terrestrial telecom systems, with regard to interoperability, we, the industry, are not good. This has not been a success story to date. So the ability to take advantage of the appropriate tool for the appropriate job, to take advantage of that diverse array of architectures and systems to meet specific requirements. In order to do that, you've got to not only have one terminal that works with one system, and ideally you would be able to be dynamically moving from space to terrestrial. How optimistic are we that we're going to see some real progress there? Nick, do you want to kick off talking about that a bit?
Sure, yeah, thanks, Carissa. I think, yeah, really key issue, I think, coming back to what Doug mentioned earlier about the mission aspect and the user, this is really key. How can we ensure that, you know, that some people quote it as a nirvana, you know, multi-band, any terminal, any network going forward, any orbit. It is really, you know, a great opportunity for the government user, would say, and to really put in that diversity that we need to get the resilience through the networks. So, I mean, there are some very interesting companies out there coming forward with terminals and technology, flat panel and other type technologies, and we're seeing some demonstrations. So I think it will take some time to get into the actual use. I think we also need to be careful of the type of platform that's being used, if it's a land or maritime or aviation platform. And some of the issues to do, you know, for example, in the maritime domain, you know, it's not always easy to put multiple terminals on a ship. And you know, maybe they carry lots of different terminals at the moment, but they, you know, it might be better that it's a LEO or a GEO network, depending on its operational requirements. So again, it's coming back to what really does the user need. There's definitely not a solution for everyone. I think we need to tailor it and see things going forward from that perspective. So, but there's some really interesting developments out there in the market that we're tracking closely.
So Jerry, Telesat is, you know, this is an internal problem for Telesat, not an external theoretical problem, at least with regard to LEO versus GEO interoperability. How do you see the future playing out? How optimistic are you about that?
Right, so terminals are key, right? That's is the phraseology that we always use in following the U.S. DoD's activity, is follow the terminal. Serve the terminal that's already deployed, because that's the use capability. We have those same problems here in the LEO or GEO. It's the same scenario. So the ecosystems have to be put in place that allow for the rollout of a terminal that can be multi-orbit regimed, whether it be LEO, MEO, or GEO. Some of those systems are being deployed today. We saw work with SMC already where they've looked at flexible modem interfaces and a means to provide a terminal that can share across multiple networks just by simply changing the waveform or the parameters you're using on different networks. So those pieces are being brought to bear. So the front end is obviously the hard piece, getting the aperture right and getting the RF with multiple frequencies aligned. But the back end is through modem switching, modem cards, modem updates. So as we look at it from a LEO domain, obviously it needs to be a very large, you know, motorized activity or ESA activity. If that's, as we're moving in that direction, as Nick points out, there are antennas moving in their general directions, just not there yet for prime time. So you're still left with the parabolics that are in play today. But again, it's the back piece, that modem, that also drives the ability for the interoperability, and have the back end being an Ethernet connection. So it just plugs up into the wall, as the phrase goes. So whatever's in the wall is what you push back out from your backside of your from your modem. So we're looking at that from that perspective, getting the right modem interface established so that we can manage and control our network, and a LEO network, and also bring our GEO to play into this mix as well, but also then have the aperture that can support those multi-layer regime. I think is really where we drive the bigger problems, is getting that terminal that can do. There are terminals that can serve multiple regimes today, but they're complex. They are, you know, they are not cheap, as the phrase would go. They're not a Starlink, you know, throw on the table type scenario. They need to be robust to sustain the environments they're going to be pushed into. The northern latitudes are not going to be pleasant for those type of terminals, and so they need to be robust in that area, along with, you know, other areas as well. So I would see these as the real challenge for us, and working with our partners to try to develop that type of system that then can go across the globe, drop down anywhere it needs to be, and provide those type of services that's required. So it's a long putt, as the phrase goes, but I think we're in the mix.
So Doug, Nick and Jerry, both from the operator perspective, are basically saying, we absolutely see the value in that. We are absolutely moving toward that. And that is challenging. There are non-trivial challenges. Can you put on your military customer hat and talk a little bit about, so operators making these investments, solving these hard problems, the incentive to do that really comes from a customer that is interested, the customer that's willing to lean forward on that. How does it look globally, not just from the U.S. perspective, but what's your take?
Yeah, absolutely, Carissa. I mean, so, Jerry and Nick have both discussed the sort of the technical aspects of how do you get this interoperability. I don't think anybody mentioned software-defined radios specifically, but that's part of this process as well. I mean, it's kind of interesting with the combination of technical solutions such as ESAs and software-defined radios kind of at least tell you have the pieces to be able to make this happen, right? And now you've got to go ahead and figure out how to put them into something that you can buy and is affordable and can be installed. But to your question of the uses of this, this is one of those things where the question is does the military solve this problem, or does the commercial world solve this problem first? And I hearken back to cell phones, and for all of us who remember the first cell phones that we owned, and mine was like this big, and it only worked on one network. And if I was out of range of that network, or if I went over, oh my God, if I went overseas, forget it. I could not use that cell phone anywhere. All of the standards were different, the waveforms were different. All of the protocols were different. Sometimes the hardware itself was just incompatible. Things were bad, and so you would have a lot of dropouts. And cell phone companies recognized that, while it may not seem immediately financially viable to allow somebody else to sell the right of my network, if that attracted more users, then I could go ahead and get a better experience for the user, and therefore I would go ahead and get more revenue at the end of the day. And so today, we almost never run into the situation, certainly within much of the world, not all of the world, but much of the world, we don't run into the situation anymore where our cell phone doesn't work. It typically works no matter where we go. And that was solved by the providers because it was a better revenue for them. That may or may not be solved by providers for the military, because the military may be the one that demands a solution to this. Other than they may be the only ones who demand a solution to this, versus folks that are in the commercial world, which are happy to go ahead and put an antenna on the top of their Walmart and use that same service for years on end. The military can't do it that way. So the question is the military population large enough to get people to make this merger happen on their own, or do we need to go ahead? Does governments need to go ahead and make specific investments? And what the governments have decided to do thus far is to make specific investments. And Jerry already talked about some of the efforts coming out of the Space and Missile Systems Center. You see some of the same efforts coming out of NASA, by the way. NASA is also looking for frequency flexible modems for their communication needs. So I think this is going to be a combination of the willingness of the commercial world to support such non-specific use for their customers, and the willingness of the governments of the world to invest in these things to encourage the providers to meet that requirement. And I actually am very positive this is going to happen, because you cannot go ahead and get the benefits of these systems and these diverse systems that we've talked about until you solve that problem.
So let's pull on that thread of government engagement with industry, and in particular, the question of whether a military organization should own its own satellite system, whether it should operate its own satellite system, is a persistent one. There's obviously benefit in buying commercial services. You're able to buy by the yard, you're able to leverage commercial investment, you're able to have a much more diverse system for the same budget than you would if you only built your own systems. And this is a persistent question, and not one that has a clear resolution. Nobody's come up with a definitive answer one way or another.
Maybe we'll be the first.
Perfect. We've got at least 10 minutes. I think we should be, we've got plenty of time to do that. So I guess the question that I would ask though is, really, how does that question of make versus buy, of services versus operating your own system, how does that question change when you're thinking about a massive constellation of small LEO satellites offered by a commercial provider, where there are multiple commercial providers in a highly competitive environment seeking to serve what are in some ways unproven markets for purposes of space systems? So there's competitive risk, there's commercial uncertainty. How does that question of what do military organizations do about acquiring that capability? How does that change when you're thinking about LEO systems? And Jerry, do you want to kick off on that?
Yeah, and I think really it comes down to the mission, right? This is the key in my mind as to how you differentiate a purpose-built system versus a commercially augmented system. What is the mission that's trying to be fulfilled? Clearly, when you look at the advanced EHF, you look at Milstar, I mean, they were dedicated missions for specific purposes that the commercial industry has no place in that marketplace. They really have no place. That's, the government doing government business, as the phrase goes. But then there are the areas where it's the commercial backhaul, it's the data dissemination and distribution activities. That's all within the sphere of, it can all be managed, if you will, at the origination point and the destination point. So the information flow just kind of transverses across what I'll call a conduit, that being the satellites or a pipe. So there are opportunities where commercials can also provide for the surge capabilities when the government systems are already at capacity or demand higher needs, given a cluster of information flow. I think, as Doug alluded to earlier, if you were to try to pop everything into one geographic region, there is really never enough capacity to support all the users. So you'll need surge capabilities, and you'll need to offset some of that services onto the commercial side to achieve that. And we saw that throughout the Iraqi activities, where commercial brought satellites into theater purposely to provide services and solutions that were underserved, because it just wasn't a theater that was big enough for the marketplace as was. So I think they exist together, but I think the mission drives which solution works best and how they're managed through that process.
Doug, what's your sense of that? Are there additional complications that arise with a LEO constellation?
I don't know if there are additional complications. I think there are different complications. I mean, and we just talked about one of these things. I mean, one of the hallmarks of a LEO constellation is it's going to be a processed system, which means I can't just take a system that was built for the generic KU, C band, X band transponder and use it anywhere. I've got to go ahead and meet all of those specific protocols and setups that the system has, and that experience isn't going to be as similar across systems. Jerry mentioned much earlier about, for example, almost all commercial SATCOM systems have channelization, which is the same. So whether or not I point at this satellite today or this satellite tomorrow, my experience will be the same. Versus if I use OneWeb versus Telesat versus Starlink versus Kuiper versus anything else, my experience is going to be different on each of those systems, because they have different technical characteristics. So LEO has a different set of complications. I want to go back to your first question, Carissa, is should we buy? Should we buy? Should we own? Should we rent? Should we lease? How should we do this? And the answer is yes, of course. We should do all of those things. I often think about in the military, we have these things. They have four wheels on them. They're called cars. Nobody would ever think that the military happens to be maybe the biggest single purchaser of automobiles in the country, but they probably are. They're probably the single largest customer for automobiles in the country. Maybe Hertz or Avis outdoes them, but it's still we still got a lot of cars. But that doesn't prevent us from building Jeeps and Humvees either, okay, which are still four-wheel vehicles, but they're particularly designed for that military mission. So we'll buy hundreds of thousands of cars off the assembly line, which is just like your commercial SATCOM. But we're also going to design cars specifically for our mission, for what our mission needs. And we have never, nobody has ever complained in the automobile industry that I'm aware of. It's like, you need to stop building your own Humvees and buy our cars. And yet we seem to have that argument all the time on commercial SATCOM. And when you phrase it that way, you can see how, I don't want to say how ridiculous, but how silly the argument is, right? As Jerry said, there are some specific needs that the military should buy for. And in fact, what I'm happy to see is that the military more and more is focusing their needs down to those specific needs and recognizing that, yes, indeed, then accessing the rest of it from the commercial world, either in its pure commercial form or a slightly modified commercial form where we make some investment with the commercial world to go ahead and put in some specific things we might need, some extra security or some extra channelization. Those kind of arrangements are typically much better for the government than us going out and buying our own separate LEO constellation. Remember, if I buy my own separate LEO constellation, then I've suddenly gotten rid of that diversity that we talked about earlier as being one of the benefits of having all these constellations. So yes, we should do both, of buy our own and use others, and B, we need to go ahead and avoid the trap of thinking that our own investment makes us better. Our own investment could go ahead and harm us when we think about diversity.
That's a very compelling argument. Of course, just to speak to the automobile analogy, where it gets a little trickier is if you're in a situation where the military making 10% fewer of its own cars would mean it would have another manufacturer available. And so that broad trade space, the edges of that are where, as I know you well know, where that gets very messy. Mm-hmm. So Nick, you are chair of UK Space. UK space industry encompasses manufacturers, encompasses service satellite operators, encompasses companies that are very focused on the military as a customer. So this is this question of government-controlled versus commercial is certainly one that you've spent some time thinking about, perhaps in terms of a current large program that is under discussion in the UK. What are your thoughts about, particularly with regard to LEO systems, that buying versus services versus operating a government system?
Yeah, it's a key issue, and obviously we've got different governments around the world with different capacities in terms of acquisition and cost and so on. All of those play in. I think it's a very interesting one, and I think from Inmarsat's perspective, I think we're going to see governments, certainly our bigger customers, government customers, always having a level of ownership, I think, as Doug outlined there. The real winners here to get that diversity is going to be who has the best management capability to integrate commercial cross-military correctly, both LEO and GEO domain and others. I mean, one thing we say in Inmarsat, we want to be our customers' best second choice. We don't want to be that. We don't want to provide. That ownership's always going to be there, but how can we augment best? How can we be there, close to where the missions are needed? For example, offering a new HEO system for the Arctic, which we're going to launch next year in partnership with Space Norway and the US Air Force. That's a really great partnership there, and that we will provide MIL-KA to the Arctic for the first time. So I think it's the management capability, getting that operational as the US Space Force's enterprise management framework outlines. That's going to be the real winner here.
So this has been such a robust discussion. We could continue this for quite some time. We're running out of time. So let me ask a closing lightning round question. So top answer, as you look toward the future, what's a major risk that you're concerned about with regard to the emergence of LEO capabilities, particularly? And what's a major opportunity that you would highlight that you say, this is really important. We want to make sure that we take advantage of this opportunity. And Doug, I'm going to be terrible and ask you to be the first one to answer that.
Sure. Thanks, Carissa. Well, look, this may be a little bit off the normal perspective of a military answer, but I'll tell you, I'm going to go back to something that Nick said earlier. A major risk right now for LEO is if we don't go ahead and get our space traffic house in order. I really do believe this is this such a great capability here that we're seeing come out of the commercial world, and it's literally fantastic. And I think it's a credit to the industry to see what's happening. But if we don't go ahead and get our space traffic house in order, we could see a very dark future for this industry. And I think this is a government responsibility that we have shirked thus far, and which we now need to go ahead and take care of. So that's a little bit off the communication topic and more to the how do we manage space for the long term. But I think this is very critical. Certainly, it's not going to be that hard if we only have U.S. players in this space, but or Western players. But this is going to be an area where many nations and many companies are going to want to go ahead and have satellites. We've got to go ahead and get that house in order. That's critically important. I think some of the real promise here of what I see, on the other hand, is that I believe this is going to go ahead and become very much like I mentioned in the cell industry before. I think you're gonna see people recognize that that providing a way to go ahead and use all of these capabilities as a cohort, as opposed to an individual system, may end up being in the best economic interest of all the companies. That's not going to happen yet, but I see a future where that's going to happen. I think it's very exciting, very exciting. And I think the most exciting part of it is a secondary output of these large communication constellations is satellite manufacturing. Satellite manufacturing has revolutionized what we now think we can do from space, and paired with the less expensive access to space that we see, this has made space now accessible to everybody who wants to get to space. And that, I think, is the biggest revolution of all time. And a lot of that is powered because of these large constellations. The economics only worked if you solve those two problems, and we are now solving those two problems.
So risk, space traffic management, opportunity, a joyously integrated future. Harry, what's your lightning round risk and opportunity answer?
Right. So I think I kind of agree with what Doug is saying earlier. However, as we look at the future growth of technologies, optical intersatellite links is going to be key to that piece, both as a challenge and as an opportunity to allow for interconnectivity across the globe. So disparate regions can now be actually directly tied into population areas and the growth. So it has both the risk and the reward that comes from it. One is the interoperability piece, finding folks that can build to a standard so that any manufacturer to maintain a diverse marketplace and opportunities and various suppliers in that marketplace, maintain an industrial base, all need to find a way, as Doug was alluding to, as a cell phone model. It's the same model we're trying to look at here now under the optical ISLs. Can we get that alignment of the industry? Can we get them thinking about how, although it's maybe counter to their proprietary capabilities, but again, would allow for a broader use, of broader access, and broader market penetration for themselves. So that's kind of the biggest challenge and opportunity I see coming forth that the LEOs are going to bring to the table. And added to that is the same piece of the terminal piece we had a conversation on earlier, bringing those into bear, leveraging small apertures, electronically steered arrays. These things, again, are opportunities that allow for smaller capabilities, more portable and diverse type sizing and whatnot. However, again, it's the challenge of getting that technology developed and brought into bear into that mass production environment and having it come into price points that are obtainable. So the 2 points would be the terminal piece and also the optical ISL piece.
So Jerry's answer is technology, both opportunity and risk. Satellites talking to each other and satellites talking to the users. Fair enough. All right, Nick, it's up to you to bring it.
Okay, thanks. Well, if I may, I know you asked for one, but if I can just two risks. I see, great opportunity with the LEO constellations that are coming, but are all of them going to make it commercially? I think that's a lot of the industry is talking about at the moment. Elon Musk up there saying 0 constellations have made it so far. It looks like there are going to be some, but how many will really make it? So I think that's one. The other one I'd mention, which we haven't talked too much about, is spectrum and regulatory, and the incursion of other communication networks. We need to make sure we protect the satellite environment in that area, particularly from 5G, which is also an opportunity. And finally, in terms of opportunity, I'd say options is really, there's so many options out there for governments now. And I'd suggest to government buyers, don't close down all your options, look at the opportunities there in the market and building that diversity to your network.
So Nick's answer is the risk. I think spectrum is a really important topic, and the opportunity is embrace complexity, embrace the emerging diversity of the market. Government decision makers recognize that a more complex decision is potentially a better decision in the future of accessing using telecommunications satellites. With that, I think that we are at the point of wrapping up. I want to thank you all. This has been a marvelous conversation. Again, I think we had the exact right people here to really explore this issue. I want to thank the organizers for putting this event together, and I look forward to the opportunity to speak with folks at APSCC again.
Thank you very much for that, Carissa. Thanks, Doug. Thank you, Nick. And thank you very much, Jerry. Great conversation, really interesting insights, and hopefully thought-provoking conversation. So please join us for the ongoing series. We're doing this every Tuesday at 9 o'clock Hong Kong and Singapore time. If you're interested in upcoming subjects, please check out the website at apsccsat.com, apsccsat.com. You'll see a link for registration, which you've obviously already done because you registered for today's series. But also you'll find a listing of upcoming topics that we'll be looking at. The schedule changes from time to time, so please keep abreast of things by having a look at that website, apsccsat.com. And of course, if you're interested in joining APSCC, you can check us out at apscc.or.kr. That's the main website. Thanks again. We look forward to seeing you here again soon at the APSCC webinar series. Thanks again.